So far, we have been working with scatter data, discrete values of data. Say for example, here you have x and y. So the points are 0, 0, 0.51, okay, 1, 0, 1.5, -1, and 2, 0. And if we create the scatter plot like this way, a scatter plot, so we are going to see this scattered data. Okay, data is scattered, not connected. Okay, um, you can change the axis to make it look make the visualization is more clear. Okay, let's make it from -3 to 3, comma -3 to 3. Okay, now as you can see, this is the data. Now what if instead of this like this of scattered, instead of doing like this way, what if we want to connect the points? Okay, I want to connect this point to this point, this point to this point, and so on. Okay, to connect the points, there is another function that is called plot. I'll just write plot x comma y. Okay, as you can see, let's change the axis. Okay, so as you can see, remember plot, how the plot actually is connecting. Plot connects the first point to the second point to the third point to the fourth point, and so on, like this way. It doesn't connect first point to the third point. Okay, the serial is maintained. This plot function maintains the serial first to second, second to third, and this one. Okay, now as you can see, this is looks like more like a triangular wave. Okay, we can actually use the grid on. Okay, so it looks more like a triangular wave. But what if we want to create a sinusoidal wave? Okay, how to do that? Sinusoidal wave. Now, since sinusoidal wave is a wave shape, I need actually more data points to visualize properly. Okay, otherwise they will be connected as like this straight line. But for sinusoidal wave, I don't want a straight line. I want something like this, right? But if I use the plot, it will just connect like this way. It will just connect like this way if I give a scattered point like this way. So I need continuous set of data. Okay. uh, if you remember, the equation of sine is y is equals to a sine twice by ft. E is the amplitude of the wave, sine is the function. Okay, pi is represented by this one. Just like write pi and it will hold the value of 3.14. F is the frequency, okay, and t is the positions. You can think of it like the x. You can think of it like the x value. Now let's do something. So far you have created an array like this way. 1 is to, say for example, 0.5 is to 3. It will create point like this. Now there is another function that is called linear spacing. Okay, linear space. I will start with 1. I will finish at 3 with the increment of, no, with the number of points of 5. Understand? For linear space, this is the starting point, this is the ending point. This is not the increment, rather the number of points I want. Okay, so let me write it here. I have linear space. Okay, start, okay, ending, number of points. Okay, so the third argument is actually number of points, not the increment. Okay, don't make that mistake. Okay, so when I have this kind of linear space, so I get 5 points. Say what if I want more than 5 points, say 10 points. So as you can see, linear space function divide this range 1 to 3 equally. So that is why linear space, it is dividing this within this range, equally dividing. Okay, the distance from this to this is same, distance from this to this is same. Okay, this way, linear spacing. Okay, so that's the idea. Now, okay, now so let's go to our main task, that is I want to create a sinusoidal wave like this. So we create something like 0 to 10. Okay, let's take only 10 points. Okay, so this is my x. So my y is, let's make the 3 into sine. 3 is the amplitude, sine 2 multiple pi multiple frequency, say 1 for now, and x. Okay, these are the values of y. for corresponding points of x, these are the values of y. Point to point connection, that's the broadcasting we're talking about. Now I just want to plot x comma y. Okay. If you remember, when I'm plotting, this point will 0 0 is the first point, 0.22 to 2.95, this is the second point, and when I'm calling this plot function, this point will be connected to this point will be connected to this point, and so on, this like this way. Okay, and if I plot it, this will be gone. It's okay, completely fine. As you can see, the plot is not like a sinusoidal wave. Okay, it is close to sinusoidal wave, but not, because when I'm connecting these points, as you can see, the points are connected as a straight line. Okay, so what if I want to take the wave shape, I need actually more points. Okay, let's give you the example. So instead of creating 10 points, what if we create 100 points? Okay, let's make the y is equals to, I'm suppressing the output so that it doesn't appear here. Now we can see x and y are 1 by 100. Okay, the dimension has to match. Okay, then I call this plot function. Now as you can see, you are visualizing this nice sinusoidal wave. Okay, now we can also change the axis, okay, to make it much more clear. Okay, let's I'm starting from 0, so let's make it -1. Oh, short, sorry. Oh, sorry, I make a mistake. This is the x, this is the -x to +x, this is -y to +y. Okay, now it is now this is the sinusoidal wave that we want to create. Okay, now, so I believe you got the idea how to create a sinusoidal wave. To plot a wave shape, to create this kind of continuous data, I have to create many number of points. Okay, 5 or 10 points, this will look like a straight line, but I have to create these multiple points, 100 points, 1000 points, like this way. This will the points are from 0 to 2, and there are 100 points within. Okay, that's the concept. Now say I want to create another sinusoidal wave, but instead of doing in another figure, you remember the figure command can do it, also the subplot command can do it. In the same plot there could be a different plots. Okay, but instead of doing either of those things, I want to create another plot in the same window here, in this in top of this one. Okay, so if I want to do something like that, okay, I have to call another function that is called hold on. Okay, hold on will actually hold this picture, okay, hold this figure, and the next thing I plot will be in this plot. Okay, let's see what I do. I keep everything same, but I just change the frequency to 2. Okay, let's see how it happens. Why it is not output? Okay, let's plot it. So as you can see now, there are actually 2 plots on top of each other, and MATLAB automatically sets different color for different plots. So this blue one was our first plot, and the next one we increase the frequency, so this is actually the second one. Okay, now let's keep the hold on. Okay, now let's plot another one on top of that. This time what I do is I increase the frequency, so I increase the amplitude, okay, and keep the frequency high. Now let's plot. As you can see, this is the third plot. Okay, so on in this way, in the same plot, okay, I can actually do multiple plotting. Okay, now if I do not want this anymore, I'll just write hold off. Okay, it will actually hold off. Okay, it will actually remove this command, and this hold on, I have to finish it with hold off. Okay, that will remove this handle, okay, this function handle. Okay, so I believe you got the idea. So this way you can actually create plot. So these are the things that you have learned so far. So bar plot, then you have learned this plot. Okay, you have also learned another thing, important concept, that is called hold on. Okay, now, and similar to linear space, there is another function called log space. Okay, it actually creates logarithmically separation. Okay, so I hope you have got the very basics idea how to do different kinds of plotting. Okay, now before I actually leave, there is one thing I wanted to share but I missed. So last time we actually did some created a triangle. Okay, if you remember, from 3 points. Say for example, x equals to 3 comma 4 comma minus 5. That was 1 point, and y is equals to 5 comma 9 comma minus 8. If you remember, this was something we did. Now what if we want to plot it? Okay, let's plot it x comma y. As you can see, the plot is not actually working properly. Can you understand what is the reason? Can you guess? As you can see, our first point was 3 comma 5, 3 comma 5 somewhere here. So first point was connected to the second point was connected to the third point. But what if we do something like this? Instead of plotting it, what if I let's do a scatter plot. Can change the axis. Now as you can see, the points are like this way, and it should create a triangle. If you remember, okay, if you can see, if you think this can be a triangle, but how we can do that? So in order to do that, I have to place the points serially if I want to use the plot function. Okay, but there is actually a much better way to do this kind of shape, create this kind of shape. Okay, this polygonal shape. To do that, there is the, let's do something like this, that is called poly shape. Okay, poly shape x comma y. Now try to understand. So this poly shape is not actually creating a plot, rather it is creating an object. It is creating a poly shape object holding P. Okay, so this is the vertices, number of regions, and so on. If I want to plot now I will just plot like this way. I'll just call plot P. As you can see, the triangle has been plotted. Okay, so what we do actually, we create a poly shape object named as P, then we plot that one. Okay, then we plot the object that will create that triangular shape. Okay, and on that object like this P, okay, we can actually find out the area. Say for example, if I want to find out the area of P, so the area is 9.5. If I want to find out the perimeter, okay, other ways like this way, you can also do that. The perimeter is something like that. You can also calculate and check whether it is correct or not. So similar to triangle with 4 points, you can create a quadrilateral. Okay, you can actually create hexagonal and other kinds of shape. Different kinds of poly shape object can be created by this command. Okay, poly shape. So I hope it is clear. Just to remember, this poly shape will create an object. Okay, it is not going to create a plot. It is going to create an object, and on that object I can perform different operation. You can search the documentation and you will see different kinds of things. So let's go to the documentation a little bit. I have created, let's see. So in the documentation you will find there are actually many things. Now within this short time I cannot cover all of those things. Okay, but I believe if you try to take a look, just go through the lines. It is not complicated, and since there is the example is also given, also shown, if you look at the examples you will see how they are actually working. Okay, so try to take a look at the examples. I believe it will be clear. Okay, if you want to work with those things. Okay, there are lots of things, lots of additional things that you can do. Okay, so for example, if I write this will create the marker type, and if you go to the example option like this way, and you will see how it can be done. Okay, now one other thing, same for axis, you can actually try to take a look how this is actually working. So I was using this option, axis limits. If you take a look at the histogram, I use the first two. I only showed you the first two. You can also add some other things as well. Okay, there are lots of things that you can do. Also say look at the poly shape, then inside the poly. Okay, you can actually create different kinds of shape like this way. Okay, and you can work with those things. So I hope with this you can actually do the very basics fundamental plotting. Okay, and remember these things. You need to add these things to your plot. Okay, adding these things to your plot will actually make your plot make more sense, make your visualization make more sense. Okay, I hope it is clear. Let's finish it down.